Hey everyone, welcome back to Tank Control Games. This is episode 4 of my surface detection series in Unreal Engine 5, and today we're setting up dynamic footprint decals that spawn based on surface type. So you can see as I move across the different materials, footprints appear, fade over time, and even change texture the further you get from the surface. If that sounds useful, drop a like and subscribe, and stick around for the full tutorial. And if you haven't caught the previous episodes, they're linked in the description below. Before we dive in, I've linked some free footprint textures from Resource Boy in the description. I've also included a small curated set of that pack that I've already resized to be 1K instead of 4K and turned into alpha textures in Photoshop. You're totally free to use any footprint textures you want, but I highly recommend keeping all of your footprint decals the same size and orientation. If they're all different, you'll end up needing custom offsets for each footprint, and that quickly turns into a huge pain. So once you have your textures ready, let's open up our Unreal project. Okay, so when your project loads, make sure that you have added your textures. I added mine under Textures, Footprints, and then there's these 4 textures from the zip file. And you'll see the previews look a little weird, but if you double click them open, you'll see the real texture, and it's just a white footprint with a transparent background. And then we have heavy and light, and I did 4 just so that we can have kind of a progression from like a full footprint to these lighter footprints where it's a little bit of a partial footprint. And you can add more or less of these, but this was kind of the minimum to sell that idea, so I just added these. Next, let's open our third-person character. So in the event graph, let's go to where we're setting our current surface. I'm just going to remove our print debug for now. And then instead of just setting the surface here before running our movement setting logic, we're going to do a function here. So let's collapse this to a function and just rename that set surface. And then double click inside that function. And then instead of just setting the current surface, we also want to store the previous because we're going to use that in a second. So let's add a sequence node and then hook that up first. And then the first thing we're going to do before actually setting the current surface is set the previous surface. So let's add another variable. So duplicate our current surface and just name it previous surface. And then we're going to set the previous surface to be the current surface. Because if you set the current surface first from the input we're getting here, it'll override the previous surface instantly. So we actually want the existing current surface to become the previous surface. And then we can set our new current surface just like that. Cool, so then let's go back out to our graph, and then after we run this function, we can just do our sequence like before. And then we're still setting our character movement settings. And then if we go to the second part of our sequence where we are switching on E physical surface, which was currently doing nothing, we are going to use similar to this, but we're actually not going to use the current surface, so let's delete that. But we are going to do stuff off of the previous surface. So let's get our previous surface variable, and then let's do switch on E physical surface. And then we want to do this off of what the last surface was. And the reason we want to do this is because we actually only want to bring footprints from one material onto another material. We don't want to leave snow footprints on the snow. And that's because we're actually going to do a different method for that later on, where we're going to leave depth footprints that kind of melt the snow away. So for things like mud and snow, we're going to do a similar method. But we do want to leave footprints when we're coming from those materials onto others. So that's why we're doing the previous material instead of the current material. So what we can do is hook up our second pin of the sequence to this, and then we need some variables that we need to keep track of for these materials. So let's add a new variable and call it footprint color. And then this is going to be of type linear color. And then we need one for our starting opacity for the footprint. And that'll be a float. And then we need one that keeps track of when footprints are active. So once we come from a previous surface that should trigger footprints, we need a Boolean that says to print the footprints. So do Boolean and then name that footprints active. And then we need another float, so just duplicate starting opacity, and let's name this footprint start time. And then let's duplicate that one more time and do footprint strength. So for footprint strength, let's make that have a default of 1. And then let's actually add one more float. So let's duplicate and do footprint duration. And then let's set that default to like something like 3 for now. Okay, so we'll set up the snow path first. So the first thing we'll do is we'll set the color. And we'll just make that white. And then we can do our starting opacity. So for something like snow, we probably want it to be thicker at the start, or probably as thick as it can be. So we'll just do our starting opacity at 1. And we can set if our footprint is active. So whenever we cross through something, a previous material that will leave footprints, we want to set it to be active right at the start. And we want to store our footprint start time. And to get this footprint start time, what we need to do is get game time in seconds. Then we'll set our footprint strength, which should start at 1. So basically what we're going to do is over time, we're going to also decay our footprint strength, which will decay the opacity too, and we'll kind of use that to drive those variables. So starting, it'll always start at 1. And I'm going to move our footstep logic here just out of the way so we have a little more room. And then what we can do is set a timer by event. And then let's make a new custom event. And let's just call this footprint decal timer. And then we also want to store the timer handle, so we'll just promote that to a variable and call that footprint timer handle. Cool, and then this should be looping, and then for time, let's do 0.05, and everything else can stay the same. So now what we can do is we can set our footprint strength. So this will get set every 0.05 seconds of the timer. And what we're going to do for that is we're going to create a new function. So let's do new function and name it footprint strength decay. Okay, so what we can do in this function is we can get game time in seconds again, and then we can subtract this from our start time that we set outside of here. So basically when you get game time in seconds, you're storing that exact time as the start time. And then we can subtract that from the current time. And then you can just hook that up like that. So then we can divide that by the footprint duration. And the footprint duration is basically how long you'll leave footprints. So if you set this to 3, after you cross over a material, you'll just leave footprints for 3 seconds. Then what we can do is we can clamp that value. So do clamp float, and then min will be 0, max will be 1. And then we can just subtract that by 1. So add a subtract node and just do 1 minus this value. Then we can hook this up to the return node. Just like that. Cool, so now we have our footprint strength decay, and we can use that here. So we'll just make that function pure, and then drag that into our graph, and then hook that up to footprint strength. So what we can do after that is we can take that footprint strength and then check it against, see if it's less than or equal to 0. And then if it is, let's add a branch. And then when it is 0, that's when we want to stop printing footprints. So what we do is set footprints active to false. And then we can just clear and invalidate this timer. So let's get our timer and then search for clear and just hook that up like that. Cool, so then we can test this out and just take a look at what's going on here. So let's add a print string. And then let's just hook up footprint strength to it so we can see our footprint strength displayed as our timer's going. So do compile and then click play. So let's cross over a material that's going to leave footprints. So while we're on it, it's not going to do anything. But once we leave, you'll see our timer, our footprint strength decaying, and it decays all the way to 0 and then stops and the timer stops. Cool, so let's remove that print string. That's all working. Next, what we can do is go back to our footstep logic, and then let's do one thing here. Let's actually collapse all of this to a function. So each of these functions, let's combine into one function. And we're just going to call this handle footstep. And then inside that function, let's go into our line trace, and we're actually going to change this around a little bit. Right now we're outputting the hit result from our line trace for location and normal. We're actually just going to store those as variables, and it's going to be way easier to use that in this graph. Otherwise it will start to get pretty unruly. So under foot trace, One other thing we're actually going to do too, temporarily we're going to unhook up setting surface type this way. And we're probably going to go back to fix the bug that this was fixing in a different way later on, but for now just leave that unchecked. And then what we can do is we're not going to return our location in normal anymore, so you can just undo both of those. But we are going to return whether our line trace actually had a hit. So if you just drag off the return value into the return node like that, that's all we're going to return now. But we are going to set some of these values as actual variables. So we want our location like we had before, so let's just promote that to a variable. Then we want our impact point, so also promote that. Our normal, our impact normal. And then the last thing that we want is going to be the player's forward vector. So we'll just do that in this function as well. So do get actor rotation, and then get forward vector, and then just promote that to a variable and call it player forward vector. And then just hook that up at the end. So we'll just rearrange these nodes slightly, just for a little cleaner graph. Cool, so that looks good. So compile and then go back out. Now you'll see your node's gonna have these red errors just to refresh. And it'll unhook that up. And then we still need to hook our normal, our location and normal up to these functions. So let's drag our location, hook that up there. Then you can just duplicate that variable and hook that up there, and then grab your normal. And then you can just get rid of these extra node paths, and then do compile again. Okay, so this will be a lot cleaner because we're going to use those variables in even more places. So what we can do also off of our foot trace is we can add a branch, and then if we hit nothing on our foot trace, we don't really want to spawn a sound or a footstep effect or any of the other stuff we're about to do. So only when this is true do we continue. So the next thing we're going to do is we're only going to print footprints when footprints is active. So what we can do is get our footprint active variable, add another branch, and then we just will do nothing when this is false. But when it is true, we're going to spawn a decal. So let's do spawn decal at location. And we haven't created our decal yet, but we'll just set up some of these settings ahead of time. So for the decal size, what I found with these particular textures is 1 for X, 15 for Y, and 15 for Z is a pretty decent size. And you can tweak that if you want your footprints to be bigger or smaller. And then for location, we're going to have to do some calculation to figure that out. So let's make another new function and just call this calc footprint decal loc. Okay, so what we're going to do for this function is we're going to get our impact point, and then we're going to add that to our impact normal with a small offset. So what we can do is do this plus, and then get our impact normal multiplied by an offset. And this can just be a float that you input. Depending on your decals, you may have to tweak this, but I'm going to do 0.3 because that worked with these. And then just hook that up to the plus, and then add a return node and just hook that up like that. Cool, so now we can drag that function out. We'll also make this one pure. And let's just hook that up to decal location. And rotation is going to be a little more complicated, so let's make another new function. Footprint decal rot. So what we're going to do for rotation is we're going to get the player forward vector that we created, and then we're going to project vector onto plane. And then for the plane normal, it's going to be your impact normal. And then we can normalize that return value. And then what we're going to do is we're going to make rot from X and Z. And then we're going to get the Z value from this normalized return value. And then we're going to get our X from our impact normal. And then what we can do is combine rotators. And then we're going to slightly rotate our decal just so it lines up better under the mannequin's feet. So if you're using a different character, you're probably going to have to use different values here, but what we can do is drag off the B and do make rotator. And then we can just manually input a yaw offset value. So I found -80 worked, and this was for the right foot when I was doing this. So this value can change, and if you have a different size character, you're going to have to probably tweak it. But for the default Unreal mannequin, this was a value that worked pretty well. Then what we can do is we want a different offset based on if it's the left or right foot. So we can add a select node, and then right now it's wildcard, but we actually want to choose this based on the current step. So whether you're doing a left or right step. So I believe that is our current step type. So like I said, when it's right foot, this is the offset that worked for me, but for left foot, we need a different offset. So let's add another combine rotators node and another make rotator. And then this will be for our left foot. And then for this, I found -110 worked best. And then we just want to return our value here. So add a return node, just like that. Okay, just to high level go over what we're doing here again. Basically, we're just making sure that our decal lays flat on the surface that it hit, and also that it's facing the same direction that the player's moving, and that's why we're using our forward vector here. Then we're just rotating each decal differently based on the left or right foot, and then choosing which rotation to use using our select node at the end. So what we can do after setting that up is just go to our calc footprint decal rot, and then make pure again, and just hook up to rotation. Then the last thing we can do is set our footprint lifespan. So I can't remember if we made a variable for that yet, which it looks like we didn't. So let's add a new one and just say footprint lifespan, make a float, and then let's make that default value for 8. So the footprint itself will live for 8 seconds before destroying itself. And then just hook that up like that. Then what we can do is we can make a dynamic material instance whenever we spawn these decals. So drag off of here and search for create dynamic material instance. So we're going to create a mid, and then let's create a new function and call it set footstep decal values. And then we'll just hook this up at the end here. Okay, so we want this function to take in our mid, so let's just add an input for material instance dynamic, and then object reference, and then just hook that up like that. And let's just call that mid. Okay, so in this function, let's add a sequence, because we're going to do quite a few things in here. So the first thing we'll do is let's get our mid, so get our mid variable, and make sure it has a little f so that it's the function variable. And then let's do set scalar parameter value. And then we haven't set up these parameters, but these are what we're going to name them once we create our material. So let's do foot mirror, and we'll just use that to actually mirror our material based on left or right. So the way we're going to do that is we're going to get our current step, so current step type, and then let's do a select node, and then just hook that up to the value. So when it's left, it'll be 0. And then when it's right, it'll be 1. And then we're going to set up a material so that these values actually drive the mirror. So just hook that up like that. Okay, then we want another scalar parameter value. And then this is just going to be strength. And then we're going to drive this parameter using our footprint strength. So just hook that up like that. And then make sure that your mid variable is also hooked up. Next, we're also going to want to track the lifespan of these decals, and we're going to use that because we're going to fade the decal at a specific time in its lifespan, so we want to keep track of that in the material itself. So what we can do is another scalar parameter value, and this one will just be called lifespan. And then we should already have our footprint lifespan variable, and just hook that up like that. Then we're going to want one for a parameter we're going to call fade out. And this is going to basically be the time that we want to start fading out the material. So we're probably going to choose to fade all the way to 0 at the end of the life cycle of the decal. So I'll show you how we're going to set that up in the material shortly. And let's add another sequence pin. And then the next one we're going to do is going to be called spawn time. And this is going to be when the decal gets spawned. And we also want to track that in our decal material. And then to get that value, it's just going to be the current game time seconds again. Just like that. And then we're also going to set our footprint texture using a parameter value. So we can do that with a set texture parameter value. And then we'll just call this one footprint texture. And then to get this value, what we're going to do, we're going to do something a little fancier. So let's drag off the value and do select. And then we're going to switch the footprints when the strength dips below a certain level. So it'll start off with your full footprints, and then as the footprint kind of decays, it'll start using those lighter footprint textures we had. So what we can do is get our footprint strength, and then we can check if this is less than, let's say, 0.7. So once it decays past 0.7, then maybe we start spawning our lighter footsteps. So you can just hook that up under index. And then what we can do here for the select, we can actually just make an array for each of these. And then let's add a new variable. So go to variables, and we're going to call this heavy textures. And then right click on the variable pin here, and it'll shift to an array. You'll see this series of squares kind of pop up. So that means it's an array now. And what we can do with that is we can hook our heavy textures up to the false. But before we do that, we're going to get a single random item from the array. So you can do random array item and then hook that up like that. So what that's going to do is it's going to look through all of our heavy textures and then just pick one. And we only have two, but if you add multiple, and you have a bunch of different textures here, this is a good way to just kind of pick a random one. So for our heavy textures, if we compile, let's also just add our array items. So add two textures, and then these are going to be our heavy 1 and our heavy 2. Cool. So then on the true, we're going to want to do our light texture. So let's just duplicate the heavy texture variable and just call it light textures. So for the light texture variable, just change the defaults from the heavy to t_light01 and light02. And then same thing, we're just going to get the variable, use another random node, and then just do that on the true. And just rearranging some of these nodes a little bit. So then the last two that we want another type of set parameter for our mid, and this one's going to be a vector parameter. And this actually lets you set the color. So what we're going to do for this is just input our linear color variable we made earlier. So our footprint color, just like that. And then let's just name that footprint color. Okay, so for this last one, we're going to do another set scalar parameter value. So I'm just going to copy these nodes down. And then this is going to be called starting opacity, which we already have our variable for. Let's drag that, hook that up. And then for the starting opacity default value, since we didn't set that previously, let's make that just 1. And then just hook the last pin up like that. And you can clean up these nodes a little bit if you want. But there you go. So now we have all of our parameters that we need to set on our decal. And the last thing we need to do is just create the decal. So what we can do is go into the content drawer, and let's create a new folder and just call it materials. And then let's do a new material and name it m_footprint. And then double click that open. So our footprint is going to be a deferred decal, and it's going to be translucent. So now what we're going to do is we're going to set up all of these parameters in our material, and then also the logic to drive them. So what we want to do first is let's make our color. So just do 3 and then click on the graph, and that'll make a vector. And then what you can do is right click, convert to parameter. And let's name that footprint color. And you really want to make sure that these names match the names we already made here. So for the footprint color, let's drag off of it and do multiply. And we'll hook that up to the B actually, and then just plug that into the base color. Okay, so now we're going to make one for the texture. So let's right click and look up texture sample parameter 2D. And then let's name this footprint texture. And then as a default, let's just make it like our heavy footprint, so just do heavy 1. Then what we can do is we take the RGB from that and let's just hook that up to the multiply. And then we can take the alpha and add another multiply node, and actually even another one after that, because we're going to do some more calculation before we actually plug this into the opacity, but you can just plug that directly into opacity now. Then we also want our alpha from the color, and then that can plug into the B of this multiply. So just like that. And then what we want next is a way to mirror our decal, depending if it's left or right. And actually I'll just go into the square view so you can see our decal kind of stamped onto the test material. So to mirror the decal, what we want to do is we want to get texture coordinate. So we want to split up U and V and can mirror this as a left and right footprint. So what we can do first is get a mask. So component mask, and then we're going to make this R only. So just set that to R. And then we can do a 1 minus and then a lerp node. And then we're going to lerp with the 1 minus. And then for the alpha there, the alpha is actually going to be our parameter for mirroring the foot. And a 0 or 1 will be whether it's mirrored for left and right. So what we can do is press 1 on our keyboard to get a scalar. And then we're going to right click, convert to parameter. And then let's call this foot mirror, and then just plug that into the alpha. Then you can plug the output of the lerp into an append node, append vector. And now we want to get our V. So when you get a component mask off of texture coordinate, R is always U and G is always V. So what we can do is drag off texture coordinate, do component mask again, just uncheck R, and then we can just plug our component mask directly into append now and just reorganize the nodes slightly. So just like that. And then just to test that this is working, if you look at the preview and then you press 1 for foot mirror, you should see now it switches to the other side. So this will let us have one set of textures for both the left and the right foot, and we don't have to have different ones where they're actually mirrored. Okay, so fading the opacity over time, what we're going to do is we're going to get a time node, and then we're going to do subtract, and we're going to subtract the time from the spawn time. So let's make another parameter and just call this spawn time. And then let's get another subtract. And then we need 2 more variables. So let's do a parameter for lifespan. And then also one for fade out. And the lifespan is just going to be the span of the decal, so it's 8 seconds as default from what we set in our master character. And then what we want to do is subtract the lifespan from this fade out parameter, which this will represent the time that you want to start fading the decal all the way to 0, which we'll want to do somewhere around like the last second of the lifespan. And then that'll basically say, like, when you get to 1 second remaining from the lifespan, start fading now. And then it'll ensure that you fade out completely before you get to the point where the decal's destroyed. So we'll just hook that up to the subtract like this. And then we can do divide. And then let's divide this again by our fade out parameter. And that's basically just normalizing that value. And we want to saturate that as well. Then we can do 1 minus. And then we're going to want to multiply this by our starting opacity and our strength. So let's add another multiply node. And we'll just hook that up to the B. And then let's add 2 more parameters. One for starting opacity. And then one for strength. And then multiply those together. And we can set both of these defaults to 1. And just hook that up like that. Let's move everything over slightly and just plug it in. Okay, so to just kind of briefly explain what we're doing here, our starting opacity is how translucent you want the first footprint to be. So when we start making footprints, if it's something like water, you maybe don't want it at 1, maybe you want it less than 1. But for snow and mud, it's probably going to just be 1. And then strength is going to be decaying as your footstep timer is running through. So that's going to be making each progressive footstep a little more opaque than the previous one. Then we're taking a look at when the decal was spawned and how long its lifespan is. And then we're choosing a time within that lifespan, which is our fade out parameter, to start fading out the material fully. So basically, as our timer's running out, when we get to whatever we set for a fade out, then we're going to fade the material completely out. And we just do that right at the very end, so that like when your timer runs out and your 8 seconds is up, all of the decals are going to fade out before they destroy themselves. So that's basically everything we're doing here. So we can click apply, and now the last thing we need to do is back in our character. We never actually set our decal material, so we just want to use our new M footprint. And then just click compile. And then now we can test this out. So let's go back in our level, click play. And there you go. Now we're starting to leave our footprints. And if we walk through mud, nothing's going to happen because we didn't actually set up anything other than our snow. But one thing we can also check too when we run through, we're printing our different footprints. They're changing texture, so we can see the full texture and then kind of the partial ones later on. And then once we ran down the timer, you'll see that the footprints fade away. So everything's working properly. Okay, so I went back to my third-person character, and then I added some footstep colors for some of these materials. So right now, the only materials that are going to leave footprints are snow, mud, water, and blood. And then I added a different starting opacity for water, just made it 0.5, so it'll just look a little more transparent at the start and a little bit more like water. So we can test this out. Let's go back to our level. And then if we go through the snow, you'll see we're leaving snow footprints. And then you can cross through the blood. You can kind of mix footprints together. There's a way to stop that as well if you don't want to leave footprints on a certain material. But you can see it's leaving our footprints, and then they're fading after 7 seconds. And then they fade out fully before completely destroying themselves. So that's all working pretty well. And let's cross over the mud so we can see that. And then we can also go on our water and leave footprints there too. All right, so everything's working now, and I think this is a good place to wrap up the video. So in the next episode, we're going to be looking into render targets, so we can do things like footprints with actual depth, and for something like snow, we'll probably have it so it melts under the player's feet. So if you enjoyed this tutorial, make sure you like and subscribe, and if you have any ideas for improving this system, drop them in the comments down below. Also, feel free to join the Discord. It's a great place to ask questions and show off what you're working on. So thank you so much for watching, and I'll see you in the next one.